Newton discovered three laws of motion. In the last chapter, we learned Newton's third law. Now we'll learn Newton's first law of motion. In Newton's first law of motion, it states, if an object is at rest or moving at a constant velocity, then the resultant, or vector sum, of all forces acting on this object is zero. Remember, it's the vector sum of all forces acting on this object. When an object is at rest or moving at a constant velocity, we say this object is in equilibrium. And if the resultant of all forces acting on object is zero, then this object is in equilibrium. Let's look at some examples. An object of 2 kilograms sits at rest on a surface. Find the normal reaction. First, let's sketch the force diagram for the object. There's weight, pointing downwards. And there's normal reaction, pointing upwards. This object is in equilibrium. So according to Newton's first law of motion, the sum of these two forces is zero. Therefore, normal reaction is equal to weight, which is 20 Newton. An object of 3 kilograms is hanging at rest by a string from a surface. Find the tension in the string. First, let's sketch the force diagram for the object. There's weight, pointing downwards. And there's tension, pointing upwards. This object is in equilibrium. So according to Newton's first law of motion, the sum of these two forces is zero. Therefore, tension is equal to weight, which is 30 Newton. A car is moving at a constant velocity on the road. There's a constant friction of 1000 Newton. Find the driving force of the car. First, sketch the force diagram for the car. Vertically, there's weight, pointing downwards. And there's normal reaction, pointing upwards. Horizontally, there's driving force F, pointing right. And there's friction, pointing left. Since the car is in equilibrium, the sum of the forces all both directions should be zero also. Therefore, the driving force F is equal to the constant friction, which is 1000 Newton. An object of 2 kilograms sits on a rough slope of 30 degrees to the horizontal. Find the contact forces on the object. As always, let's sketch the force diagram first. There's weight, pointing downwards. And there's normal reaction, pointing upwards, and perpendicular to the slope. Lastly, there's friction, pointing upwards along the slope. This object is in equilibrium. Therefore, the resultant of these three forces is zero. Let's resolve W on two perpendicular directions. One is along the slope, and the other is perpendicular to the slope. This angle is 30 degrees. The resultant on both directions is zero. On the vertical direction, the normal reaction R is equal to the vertical component of W, which is W cosine 30 degrees. It is 2 times 10 times cosine 30 degrees, which is 17.3 Newton. On the horizontal direction, the friction is equal to the horizontal component of W, which is W sine 30 degrees. It is 10 Newton. To solve similar problems, we sketch the force diagram first. Then, resolve all forces on two perpendicular directions. Lastly, resultants on both directions are zero.